Hello everybody, today we're going to be talking about simplifying square roots. So this is a review. So as you're watching it, I hope that this will, remind you of everything that you've already learned in Algebra 1. So there's a couple different ways you can go about simplifying square roots. You can look for the perfect squares that divide into it, the biggest perfect square. So your perfect squares, are these numbers right here. And we can see that if you take the square root of a perfect square, we get a nice neat number. Or we can do a factor tree. So I'm going to do both ways and let you guys kind of make the decision about what you want to do. So let's go ahead and start off with, let's do a factor tree. So with 175, we kind of have to decide what divides into it. So it looks like a 5, right? Because it ends in 5. So if we do 5, that would be times 35. Makes it a lot easier. And then 35 is 5 times 7. So notice we have a 25 and 175. So since we have two 5s, we're able to pull one out. And we have our 7 left over. Now the other way to look at this would be to say, well, I'm going to look at my perfect squares and I want to find the biggest one that divides into it evenly. So we could break it apart like this. Well, that would be 25 times 7, right? And well, the square root of 25 is 5. So if you're good with your perfect squares, definitely could be a quicker route to use the perfect square method. So again, let's go ahead and take a look at 252. And again, I kept the perfect squares over there for us to kind of keep track of what we're doing here. So hopefully the first thing you see if we do a factor tree is that this thing is even. So we can divide it by 2 and we get 126. Well, 126 is even. So we can divide it by 2 as well. And that leaves us with 63. So 63, if we're looking for the smallest thing that divides into it, would be a 3. So notice if we add the digits, 6 plus 3 is 9. Since 9 is divisible by 3, so is 63. It's kind of our shortcut method there. So we can divide that all by 3, and we get 3 times 21. And then 21, would be 3 and 7, right? So now I'm going to circle my groups of 2. So I've got a 2, I've got a 3, and then the 7 is left over. So I can pull a 2 and a 3 out. 2 times 3 is 6. And then I have radical 7 left over, and that would be our answer. So now if I want to take the perfect square method, I would check to see if 252 is a perfect square in my calculator, which it's not. So then I know I would want to take 252 and divide it by 2, and that would give me 126. So that would tell me that the number needs to be 126 or smaller for the perfect square it divides into it. So I would start, at like 121, but it doesn't divide in evenly. That's 11 squared. Then try 100, 81, 64, 49. And then once you get to 36, you'll see that 252 is 36 times 7. So then you can simplify it and make it 6 radical 7. Now, having a calculator in your hand will make these a lot easier. So here's another one. Now this one I think is pretty easy to do with the perfect square method because hopefully you look at 28 and you're thinking, 28 is 4 times 7. And the square root of 4 is 2 radical 7. And we get the same thing if we did a factor tree. We say, 2 times 14? And then 14 is 2 times 7. We can pull out a 2, and we still have that 7 left over. All right, so you're also going to come across possibility of seeing variables in your radicals, and that we work those out the exact same way. So we want to take groups of 2 out if we can. So let's take a look at 72. Let's do the perfect square method. Well, the biggest perfect square it divides into 72 is 36. So that's 36 times 2. And then we have that x left over. So the square root of 36 is 6. And there's not 2 2's and there's not 2 x's, so they have to stay underneath the radical. So if you wanted to do the factor tree here, again, we could just sit here and go through it like this. It's even. Now 2 times 36, and then 36 is even. 2 times 18. 18 is even, be 2 times 9. 9 be 3 times 3. So notice we have a 2 and a 3 that we can pull out. So we get the 6. And then we still have the x and the 2. So that would go back underneath the radical. All right, so Here's the next example. So we've got 216. I might want to, no, I'll change the next one. 216x squared y. So again, we could look for the perfect square, or we could do a factor tree, totally up to you. So I'm gonna just start with a factor tree, because maybe 216 is kind of hard to see the perfect square in there, but that would be what, 2 times 108. Then 108 would be 2 times 54. Then 54 would be 2 times 27. And then 27 is 3 times 9. And 9 is 3 times 3. So that means we can pull out a 2 and a 3. So that means we have 6 on the outside. Now we have the square root of x squared. So since there's 2 x's, we can pull 1 x out. And now since there's only 1 y, we can't do anything with that. And we still have these other 2 numbers down here that we did not have pairs for. So it would be 6x times 6, or radical 6y, sorry. So now, if we want to do the perfect square method, we could divide that number in half and get 108, and just start with the perfect square. So we'd start at 100, then go back to 81, then try 64, and we would keep doing that until we eventually got to 36. So what this is we'd have the square root of 36 times the square root of 6. We got the square root of x squared and the square root of y. So the square root of 36 is 6. So we got rid of that. Square root of x squared is just an x. And then we'd have a radical 6y left over. So we got the same answer either way. All right, so I want to, let's go ahead and try this one here. I'm not going to do the factor method here. I'm just going to do the perfect square. So 12. Perfect square in 12 is a 4, right? So we got radical 4 times radical 3. And then the m cubed, we want to break apart so we have squares. So I've got an m squared. And then I'm going to have one more m left over. And then I've got the n squared. So the square root of 4 is 2. Square root of m squared is m. Square root of n squared is n. Now we have the 3 and the m left over. So I've got radical 3m. That would be our final answer. All right, so last thing you guys need to be able to do is just simplify radicals and be able to add or subtract them. So as long as the radicals are the same, you can add the coefficients out in front. So, we could start this problem off by saying, well, these two guys are like terms. Well, I'm going to change this to a plus. So I don't want that to go to 0. So now we have 3 plus 3 radical 24. So that makes 6 radical 24 minus 2 radical 5. Now we need to simplify this and see if we can combine them anymore. So 24, the biggest perfect square in 24 is 4, right? So this is 6 radical 4 radical 6 minus 2 radical 5. So the square root of 4 is a 2, right? So we have 6 times 2 here, which would be a 12. Radical 6 minus 2 radical 5. And that would be our final answer because we cannot combine those anymore. So let's try another one here. So notice this one has 3 different radical values. So what we're going to do is just try to simplify this. So I've got 3. Square root of 12 would be 4 times 3. And I got 18. Well, perfect square in 18 is 9, so that's 9 times 2. Minus 2, well, radical 8, that'd be 4 times 2. So now I'm going to simplify all this. So square root of 4 is 2, so 3 times 2 is 6, radical 3. Square root of 9 is 3, so that would be 2 times 3 would be 6 radical 2. And then we got square root of 4 is 2, so 2 times 2 would be 4, so we got minus 4 radical 2. So notice these are the only 2 like terms, so we're just going to have to bring down our 6 radical 3, and then we're going to combine our like terms here. So 6 minus 4 is positive 2. Then we put our radical back on it, and that is our final answer.